Welcome to the WION podcast. In this episode, we reveal the science behind the northern lights, tracing a spectacular journey from solar storms to glowing polar skies and explaining why now is a remarkable time to witness them. The northern lights are among the most spectacular displays in the natural world. Also known as the Aurora borealis, this night sky display is a major reason people travel to the Arctic Circle. However, before booking a flight to the far north, it helps to understand the actual science behind this solar event and why it appears only under specific weather conditions. The entire physical process begins roughly 150 million kilometers away. The sun constantly releases a stream of charged particles known as the solar wind. Under normal conditions, these particles travel at an average speed of 1.4 million kilometers per hour. When the sun experiences high magnetic activity, it can release large clouds of plasma called coronal mass ejections. These highly charged ejections travel much faster, reaching speeds of up to 6.7 million miles per hour. They carry massive amounts of energy and usually reach our planet within 15 to 72 hours. This massive transfer of energy is exactly what makes the light displays so intense when they finally hit the atmosphere. If our planet did not have a magnetic field, these solar winds would strip away our atmosphere over time. Instead, the magnetosphere acts as a giant protective shield. Space weather reports explain that when the charged particles hit this magnetic field, most are simply deflected into space. However, the magnetic field is naturally weaker at the North Pole and the South Pole. This structural difference allows a small percentage of the solar particles to funnel down into the upper atmosphere. The geographical area where these particles enter is known as the auroral oval. When the solar particles enter the upper atmosphere, they collide directly with atmospheric gases like oxygen and nitrogen. These physical collisions transfer energy, causing the gases to heat up and release visible light. The specific colors depend entirely on the gas and the exact altitude of the collision. Recent atmospheric data shows that oxygen located between 75 miles to 120 miles high produces the most common yellowish-green color. In contrast, nitrogen creates blue or pink lights at lower altitudes, usually below 65 miles. Sometimes, high-altitude oxygen located above 125 miles creates rare red auroras. These red displays are harder to spot and usually occur only during intense solar storms. The frequency of the auroras is tied directly to the solar cycle, which lasts approximately 11 years. During a period known as the solar maximum, the sun is highly active and produces more sunspots and solar flares. Data from the Space Weather Prediction Center confirms that solar cycle 25 reached its peak in October 2024. However, the period of high solar activity traditionally extends for several years following the peak. This means 2026 remains an excellent time for travelers heading north, as they still have a mathematically high chance of witnessing frequent and intense displays compared to the quiet years of the cycle. Seeing the northern lights requires active planning. First, you need zero light pollution, which means driving away from city centers. Secondly, clear skies are mandatory. Even the strongest solar storm will be invisible behind heavy clouds. Always monitor local aurora forecast applications and plan to stay for at least 3 to 4 nights to ensure the best chance of a successful sighting. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.